Okay, ladies and gentlemen, welcome to this session, and to those who are viewing online, welcome. We have the rare privilege of being with Dr. Molina, who won the Nobel Prize in chemistry for discovering the causes of the ozone hole. And he actually discovered the causes of the ozone hole before the ozone hole appeared. And welcome, Dr. Molina. I have the privilege of calling Dr. Molina a friend, and his esposa, Guadalupe, is here. And so let me briefly start at the beginning. As a small boy growing up in Mexico City?
That's correct, yes.
What led you to build a little chemistry lab in a closet in your home?
I was fascinated with science since I was a boy, 9, 10 years old. And perhaps the way that started, that I like to read, I was reading novels, pirates, and so on, but eventually came across biographies of scientists. And so that, somehow or other, I found that extremely interesting, so I began to play with the chemistry sets and things like that, but then took it more and more seriously, so it was just fascinating.
You had an aunt who was
That's right.
a chemist, right?
That's right. And so once she found out, this aunt being a chemist, that I like to do experiments, then she started to work with me. Wow. And I was, what, 11, 12 years old at most, and we started doing the experiments that first-year college students were doing. Much more interesting than
at age 11. Okay.
So that was very nice.
And then your path through the educational establishment, you were a distinguished student all along the way, and it took you to Germany, to Freiburg, right?
That's right. That's right. Because
the center of chemistry.
That's right. Yeah. I was trying to get graduate studies. I just got a master's in Germany, but I decided to actually do it in the United States. Part of the reason is my studies were in chemical engineering, actually, because physical chemistry was not well established in Mexico at that time. And I realized I would have a better chance to sort of widen my my studies in the United States, and that turned out to be the case. I certainly learned a lot in Germany, but the American system is more flexible.
And you had the good fortune of working with the late Dr. Sherwood Rowland.
That's right. That came later. My PhD I did with George Pimentel, who was a wonderful mentor and also an expert on education, but I was just doing basic science at that time. And then with Sherry Rowland, I started to work after finishing my PhD. We were both doing fundamental science, and we both decided, let's do something more applied, say atmospheric chemistry. How do we go about it? Let's find a problem, some interesting problem that would teach us about the atmosphere. And that's how we chose this question, what happens to these industrial compounds that are accumulating in the atmosphere?
So in 1974, you and Sherwood Rowland jointly published
That's right.
a paper that served as a warning to the world that a particular family of industrial chemical compounds, chlorofluorocarbons, were changing the chemistry in the stratosphere by eating up the stratospheric ozone.
That's right.
And that resulted in not a lot of public notice, but the industry group that was making a lot of money from these chemicals actually started going after you and Dr. Rowland, correct?
That's correct. What started out as a curiosity question, what happens to these compounds, ended up with an environmental issue. We were not environmentalists at that time, Sherry and myself. And the industry thought, well, this is just speculation. We're not going to change our manufacture of these chemicals just based on a theory and so on. And we sort of agreed that we had a hypothesis at that time, and that we had to work with the scientific community to better establish it. And that's what happened. And some of that science was, in fact, funded by industry. And
then the money was cut off, and Dr. Rowland was at a more advanced point in his life and his career, so he was more visible.
Right.
But he started being disinvited from conferences. And
here's what happens. At that time, it was not sort of fashionable, I would say, for a scientist to publish in newspapers or even to appear. It was something that was seen as in poor taste, that your work should be something known to society. But of course now, fortunately, things have changed. If you have something to say that can help society and so on, it is perfectly advisable to do that. But not in the academic world at that time. That's a sort of surprising. But Sherry and I took a very conscious step. Look, we know we have this pressure to let somebody else worry about it, some environmental organizations. But that was not the case.
Yeah.
We decided we had to do it ourselves, and we had to do it at that time because of the responsibility we thought we had.
Yeah, in a very different way, at a young age, when I was exposed to Roger Revell's science in the 1960s, showing the impact of increasing CO2 levels in the atmosphere, I had the same impression. Oh, somebody's going to take care of this if this is how this works. And then when I went to Congress, I organized the first hearing and asked Dr. Revell to be the leadoff witness, and I thought my colleagues would have the same epiphany that I had had, and there was, in the current phrase, crickets. So I had no reaction. And over a period of time, I came to the conclusion, oh my gosh, I've got to do something about this.
Right.
Yeah.
That's right.
But something happened in your case. Something happened with global warming, too, with the extreme weather events. But in the case of ozone depletion, in 1986, in Antarctica, the Americans and the British and some others, but the two large science facilities there at that time, at least, were the Americans and the British. And the British were looking up at the atmosphere, and all of a sudden, there was no ozone.
That's right.
And they called their American colleagues. Turns out the Americans had programmed their computers to ignore extremely low levels of ozone because it was probably a mistake, just an artifact of the measurement. And the British said, are you seeing this? And the Americans said, no, what? And they explained it, and then they went back and undid the programming, and they went, oh no, and it was a global emergency.
Right.
So, and it was an emergency because the ozone in the stratosphere, it's confusing because ozone at the low levels is kind of smog and you don't want it. But in the stratosphere, we got to have it because it filters out ultraviolet radiation. And that filter makes life on Earth possible.
That's right. That's right.
So when the alarm bells went off, first just a brief discussion of the mechanics. Here's my understanding of it, which comes from you and Sherry. This problem occurred in Antarctica because the air above the ice mass, 2 to 3 kilometers high, is so cold.
Exactly.
Ice crystals form much higher in the atmosphere. So far, so good?
So far, so good.
Okay.
Right.
So the mechanism that you discovered required a number of elements. Ice crystals, on the surface of which ozone and the chlorofluorocarbons mix, and the chlorofluorocarbons destroy the ozone. But the other element needed is sunlight.
That's right.
To catalyze the reaction.
That's right. Yeah.
But in Antarctica, it's 6 months of darkness, 6 months of light. So during the darkness, the circular wind patterns above Antarctica form a kind of a whirlpool that creates a kind of a bowl, if you will.
That's right.
Where the ice crystals are held in place. And then in the middle of September, when the first rays of the sun strike above the South Pole, it starts that catalytic reaction, and the CFCs eat up all the ozone.
That's right, yes.
But then after the heat from the sun is absorbed for 2 or 3 months, then the slightly warmer temperatures break up the wind, and the bowl falls apart.
That's right.
And the air depleted of ozone starts spreading to the higher latitudes. Correct so far?
It's correct, yes.
Okay, go ahead.
The only thing I would add is that it was so surprising that the experts in the scientific community, most of them except a few chemists like ourselves, they thought this had to be a natural phenomenon. It was too big.
Sort of like they think global warming has to be a natural.
Exactly. But we were able to work with the community to design experiments that involved this ER2, what used to be the U2 spy plane, flying over Antarctica and making measurements that were definitive. It was very clear. The science became just like a smoking gun. It had to be the chlorine coming from the CFCs. And the chemistry with the ice crystals and so on was not known before. So that's additional work we did in our labs to really understand the nature of these sort of strange chemical reactions. So it all fell into place, and so the science became a very strong component.
So the world community, here we have the first crisis of the global atmosphere.
Right.
Global warming is the second crisis of the global atmosphere. They have a lot of things in common.
Right. Yes.
The atmosphere is so thin, our visceral impression when we walk outside this building and look up at the sky is that the sky is a vast and limitless expanse. But the pictures from space make clear that it's a very thin shell around the Earth.
That's right. I make the analogies like the skin of an apple. Okay, but this was the first time that society realized that it was possible through human activities to have not just environmental consequences that was already known some years before, but really consequences on a global scale. It didn't matter who was emitting these chemicals.
But there were not many people in Antarctica.
That's right. We were very lucky.
We were very lucky. But I remember from my college days, they used to have these things called lava lamps. And the ozone-depleted air is a little bit like those bubbles in lava lamps, and they started coming up over Patagonia and Australia. And some populations began to be threatened.
That's right. But in terms of the science, it became possible to actually see the effects on life on the oceans surrounding Antarctica. But perhaps the most important component of this was to validate the science, because the projections that had society continued to release these chemicals, then we would have effects at many other latitudes as well. And that's what we were able to stop.
I went fly fishing in Patagonia not too long ago, and the guides there say they started encountering blind trout in the streams.
Wow, okay. So that's possible. That's one of the effects. Occasionally, the ozone hole moves over the southern part of South America, and so that begins to be dangerous for people as well.
But if it hadn't been addressed, it would have progressed to the point where this dangerous UV radiation would threaten life in all of the populated areas of the world.
That's right. At least the projections where skin cancer would have increased a lot. But if we really had done nothing, recent studies, we were not daring to do those initially, but recent studies tell us we would have a disaster nowadays because it's such an important component of the atmosphere that climate would also be highly disrupted. So we know that we had really a crisis. Fortunately, we know it can be solved.
And the world's political community reacted.
That's right.
Margaret Thatcher and Ronald Reagan among them. There was a meeting in Montreal in 1987, only 1 year after this discovery, because they were able to take your scientific work that had been done a decade and a half earlier and fully understand exactly what the problem was. As soon as the emergency alarm bells went off, they said, oh, Dr. Molina's told us how this works, so we have to eliminate these chemicals, right?
Right. The first step was just to eliminate half the industrial production, and all the countries of the planet agreed. But with the science becoming so clear, the second step was to eliminate the production entirely, except allowing for developing countries a few additional years. But that's really a success story. First, the industry initially was worried that it was going to be a huge economic crisis, that we were going to lose jobs. None of that happened. Okay. Society was able to find other chemicals. We still use spray cans, refrigerators, and so on, but with compounds that do not harm the ozone layer. So society is quite capable of addressing these sort of issues. But it would not have happened. It would not happen without this international agreement, the Montreal Protocol, which is a very important precedent.
And there are a lot of lessons that come out of it. I was in the United States Senate at that point in my career, and pushed the ratification of that treaty. And I remember when so many in the environmental community said, oh, this is not enough. It's only half, and it doesn't really solve the problem. And they were right about that. But once the process of adjustment began in governments and in business, then they found pathways to go farther. Just 3 years later in London, 1990, there was another treaty to go even farther.
Even further. Exactly. They got strengthened further and further.
So it's interesting, but now we have the second crisis of the global atmosphere.
Right.
So one of the lessons of the first crisis is that these compounds, the volume was not that large, was it?
Yeah.
But actually, one way to think about this, chlorine is a trace gas, a gas found in very small percentages in the atmosphere.
Right.
But with a family of chemicals that were not invented until the 1930s and not used in any significant way until after World War II, within a few decades, this human activity was able to change the global composition of the atmosphere by magnifying the presence of chlorine 6 times over. 6 or 7 times. Am I right about that?
Well, it's even more what we call a catalytic effect, is that the single chlorine atom coming from a molecule, a Freon molecule, as it was called by DuPont at that time, a single chlorine atom is recycled. So it can destroy tens of thousands of ozone molecules. That's why we have this huge amplification factor, but it's something commonly known in industry, catalysis. But the very important message is that the environment is
vulnerable.
It's vulnerable, and it doesn't take much for human activities to do a lot of damage. We've been lucky. We have been identifying some of those possibilities, but it's not that, like many people think, oh, the atmosphere is so big or the planet is so robust that we cannot do anything to it. No, it's so clear that the activities of mankind have already changed the landscape enormously. So we have to be very aware of that.
Before asking you to apply the lessons of this drama to the second crisis of the global atmosphere, I want to share briefly for the business people in the room a story about what happened in Montreal with the business community. One of the members of the host committee in Montreal was the chairman of the largest user of chlorofluorocarbons for the cleaning of circuit boards. It was in spray cans, refrigerants, clean circuit boards. And I know about it because his company had facilities in my home state of Tennessee. And he said, we're going to be the first company to completely eliminate these chemicals. And that was followed by applause until the following Monday morning he went to his business and met with his engineers, and they said they had long faces. And they told him, we have no idea how to do this. And they searched and searched for substitutes, and they couldn't find them. But the business leader kept the pressure on. It's the right thing to do. We're going to do it. How can we do it? And then one day, one of his engineers asked a brand new question. We use these to clean circuit boards, he said. How do the circuit boards get dirty in the first place? And that led to an initiative in which they redesigned the entire process, starting to use clean rooms. They named it the no clean process. And guess what? The circuit boards produced were cheaper and better, improved the company's competitive position, improved their profits. And then he went further. He said, we're going to donate the patents to this new process to all of our competitors so that the entire industry can make this change. What a great success story. So now, just as the atmosphere is vulnerable to this one family of chemicals, it's also vulnerable when we change the chemical composition to the point where much more heat is trapped in the Earth's system. We're putting 110 million tons of global warming pollution into the atmosphere every day. And our global policy is the atmosphere, it's an open sewer, free for you to use it. Just dump all your waste there. But actually, that's not a good thing to do, is it?
Not at all. No, no. Here again, what is surprising is the amplification factor, because carbon dioxide makes less than 0.25% of the atmosphere. So it's also a trace gas. But what is very well established by science, fundamental science, what we teach in graduate school the first year or even in high school, is that that small amount of carbon dioxide coupled with water vapor as a feedback is responsible for changing the surface temperature of the planet by 33 degrees centigrade. Without this so-called natural greenhouse effect, we would not be here. Okay, so if the atmosphere were really clean without this gas, we would be frozen.
So the natural greenhouse effect is essential to life.
That's right.
That's why they call the Earth the Goldilocks planet. We don't have too little like Mars or too much like Venus. We have just the right amount, and life, as we know, including humans, has evolved, developed, appeared, been created in these precise conditions.
But the point is, that's well understood, that's a natural atmosphere. So it's not all that surprising if we have now 40 or 50% more of this gas, that the climate should do something. Okay, it's just that some people in society, because they have been misinformed, they think, oh no, there's no way humanity can do anything to the climate, such a big system. No, it's very vulnerable, and this is just a very good example of which follows from the basic science.
And the effect of trapping enough extra heat each day to be the equivalent of the heat energy released by 400,000 Hiroshima atomic bombs going off every day. It's a big planet, but that's a big effect, isn't it?
It is. It certainly is, of course, yeah.
And it not only raises temperatures, it disrupts the water cycle.
That's right, yeah. And what is, again, very important to be aware of is how vulnerable the planet is for the climate, because changing just 1 or 2 degrees, it appears to not to be very much. But we have all these extreme climate events. Things begin to change, and society, but human society has evolved, particularly in the Holocene, the last 10,000 years, with a very stable climate. So if we suddenly get these changes, it's just very damaging, very costly for society. And we're not longer just talking about what will happen at the end of the century. As you pointed out in your presentation, it's already happening. We can see all these effects.
It's already happening. In Malawi this week, 200,000 refugees from this huge downpour right in the breadbasket of Malawi's agricultural production. So all of the work to build up sustainable agriculture there and to help them get a better quality of life, what a setback. And this is happening all over the world now.
Yes, and from the science perspective, scientists are very cautious. So until just a few years ago, they were not quite sure. They were not stating very clearly whether these extreme events were connected with climate change, always acknowledging the possibility. But in the last few years, there has been a lot of additional research. What is very clear is that there is a statistical connection. You cannot tell for sure that any particular flood or event was caused by climate change, but that its intensity was increased, that's very likely. And so that's what's happening. We know that these events are happening much more frequently than they were happening before.
And if we did not, you told us what would have happened if we did not address the ozone depletion problem. What would happen if we did not address the climate, the global warming problem?
here is a point. Let me first stress the scientific community, the consensus is practically everybody agrees, more than 97% according to surveys.
Over the last year, incidentally, 99.99% of all peer-reviewed papers. But
okay. Well, they agree climate is changing. That's now, even Congress agree with that now.
No.
Not that it's changing.
That it's changing,
well, not,
but scandalously, a majority of the United States Senate voted this week to say that human beings have nothing to do with global warming.
That's why I was stating. They agree, finally, it's changing, but they don't agree that it's humans. Okay.
Well,
that's
maybe,
the point.
You know, Upton Sinclair wrote 100 years ago in my country, it's difficult to get a man to understand something if his salary depends upon him not understanding it.
Right.
You could modify the phrase to say it's difficult to get a senator to understand something if his campaign contributions depend upon him not understanding it.
That's right. But here's the point that perhaps complicates things a little bit. Even though the science is that certain, climate is a complex system. So what science cannot tell us for sure is how will the system respond if we continue with these emissions. Not in detail, but we can certainly talk about probabilities. And the concept of risk is crucial here. So what the scientific community basically agrees is that there is a very significant risk that if we do nothing, we will cause enormous damage and with economic consequences that are huge and so on. If we're very lucky, maybe not that much would happen. But we're talking about a 1 in 5, 1 in 10 probability that we will have huge disasters.
It's sort of like playing Russian roulette.
Yes.
One chamber in 6 has a loaded bullet.
Yeah. Who of you would have flown here to Switzerland if they tell you the plane you're about to fly with, oh, it has a mechanical failure, but don't worry, there's only a 1 in 10 probability that you won't make it.
Actually, Johan Rockström and his colleague have this exhibit out here that shows that even at present concentrations of CO2, there's a 1.6% chance of a 6-degree centigrade raise. If you applied that to the airline industry, it would mean that several hundred jumbo jets would go down every week.
That's right.
CNN would be catatonic. We're still looking for the one, God rest their souls. But now, to take the lessons from the ozone depletion crisis and again apply them, you were able to overcome the resistance of industry. At first they persecuted you and Sherry, particularly Sherry. But then when the crisis was so obvious, they had to acknowledge it. They said, okay, we'll do what we need to do to adapt. That's in the process of happening now with global warming. But the industry group with CFCs was pretty small as part of the global economy.
That's correct, yes.
85% of all our energy in the world comes from carbon-based fuels.
But here's a very big difference. Because energy is such an important component of economic growth and so on, it's so pervasive, the problem is much more complicated. But there's an additional factor that came into play with the politics, because climate change became politicized. And that's because there were interest groups, very cleverly, with a lot of investment, but they managed to manipulate the media, just like with the tobacco industry. So that's why there is a perception in the public in general, oh, that it's not so well established. Some scientists think it's this way, but many other things it's really not something to worry about. That's really a myth. It's a misconception. The second myth is that even if we acknowledge it's a problem, it would be so costly, forget it. No, working with economists, it's clearly very much cheaper to address a problem than not to address it. And it's surprisingly cheap if we do it cleverly in a creative way, because we can build the infrastructure needed to use energy without such a huge carbon.
And we can create a lot of jobs in the process. And we'll be able to tell our children we didn't destroy their future.
Exactly. And there were a couple of forums here in Davos pointing that very clearly. On the other hand, in most boardrooms, it's not quite yet recognized as a significant risk.
No, it's beginning to change. Now, you now spend a lot of your time trying to lead the scientific community in efforts to communicate clearly about global warming. What website can people go to get the report you wrote for the American Academy for the Advancement of Science, AAAS?
Yeah, it's a AAAS website.
If you go to the AAAS website, the document Mario pulled together and drafted is called What We Know. Is that
right? Exactly.
Is that right? And you're working on another one now.
Right.
It's the best summation of the scientific evidence. I read them all that I can find. It's the best one, and congratulations on doing that. What do you recommend for a path forward as a way to communicate the gravity and urgency of this crisis and how we can solve it?
Well, I'm involved with at least 2 different lines of work. Continuing with the AAAS project, we are working with professional communicators. And what we need to do to the public is convey very short messages, but very clear. But you have to do research. You have to see what do people understand. We scientists are not very good at that, okay? You have to do it in a professional way.
You're getting better.
But it can be done. That hasn't been done. That's to counteract this public relations campaign. The other thing I'm doing, and it's sort of working, I'm trying to communicate directly with Republicans in Congress. Of course, former Republicans that were in the...
They don't need campaign contributions anymore.
That's right. But many of them are very green, as we call them.
Yes.
They are trying very actively to work to solve the problem. But in Congress at the moment in the United States, why is that important? Because it's a bit of a bottleneck for a global agreement. Because U.S. Congress at the moment would not ratify such an agreement. But I think that's also beginning to change.
I think it is beginning to change. And luckily, a previous Congress passed a law called the Clean Air Act that gives the sitting president the authority without congressional further action to regulate dangerous air pollution.
Right.
And CO2 is a dangerous air pollutant. So the U.S. is beginning to move. It's very, I'm optimistic about it, but we have a lot of work to do.
It's still a lot of work, but what I'm trying to do with Congress is, I sent them a letter communicating with them. I've already started, but just explain to them, look, this is not rational. Maybe you are right. I'm willing to listen. If you have a very good argument, I could be wrong. But the other side of the coin is you have to be able to listen to me as well. This idea, I'm not a scientist, hence I don't need to know about this, that's not acceptable.
Now, it's not just the fact that some within the affected industries are behaving unethically by putting false messages out. It's also the fact that all of us are vulnerable to wanting to believe the myth that nothing needs to be done, right?
That's right.
And the way we're wired, so to speak,
that's correct.
It's harder to think about these global challenges that are so massive. And if it looks like it's going to be hard to solve, maybe we just won't think about it. But now that the solutions are coming into view, it's an exciting set of changes that can make life much better.
That's right. If you couple that to the idea that, oh, it's in the future and it's very costly, then you get this response you're talking about. So that's the sort of thing we're trying to change because we believe society can actually solve the problem.
And it's now in the present.
That's right.
As we saw with Superstorm Sandy in the U.S. and Super Typhoon Haiyan and the Philippines and the drought in Brazil right now and the flooding in Malawi right now, et cetera, et cetera. One final question.
Sure.
The last time temperatures were as high on the Earth as they're projected with current levels to go, how much higher was sea level?
That's a tough question, but at least several meters, okay, many feet. But it depends, again, on the projections. If you take the 1 in 5 chance, then we're talking about 10 meters or whatever.
10 meters.
But that's a huge temperature change. It's not necessarily the most likely one, but the planet has been there before, 55 million years ago. It was a very different planet, crocodiles in the North Pole. And
no people.
no people, no. So we know it would be, if this happens in just a few decades or centuries, it would be disastrous.
And it's the pace of change,
That's
again.
right. It's very fast.
That is.
When it happened before, it took tens of thousands of years, and that is considered to be very fast on a geological timescale. But just a century or two, that's really very worrisome.
So when is your next report coming out on this topic?
Well, we are expecting to do it in the next few months. Yes, to begin to better communicate to the public, and particularly this concept of risk. Many of us working with economists are trying to convey this message. This is not an acceptable risk, and we don't have to be certain. It doesn't even have to be the most likely thing.
Let me open it up before we run out of time. Yes?
So from a policy perspective, a legislative perspective, what can Congress or someone do? What specifically would you suggest be passed to change behavior?
Well, the most important thing Congress could do, if they give the message, is to approve and to work towards a planetary solution. It's likely to begin to happen in Paris, okay? But we know Congress at the moment would not ratify an agreement which would impose a price on emissions. It doesn't have to be the actual price of what it costs to do the damage. That's very hard to calculate, and it's very high. All you need is a price which is large enough for it to be an incentive to begin to use much more frequently clean energy, renewable energy, and so on. It doesn't have to be huge.
This December in Paris is the negotiation. This is the year of climate, because at the end of the year, every nation in the world will meet in Paris to come up with a global agreement. That global agreement has to cap and reduce the emissions of global warming pollution. And countries can accomplish those reductions in different ways. Putting a price on carbon is the most effective way. An emissions trading system is an effective way. Regulations, like under the Clean Air Act in the U.S., requiring emissions is a third way. But this is the year we have to take action on climate now. Ladies and gentlemen, it has been wonderful to share this time with Dr. Mario Molina. Please join me in thanking him for being here and his entire career. Thank you so much.
Thank you so much for joining me with your participation.